Hello, everybody. Hoping you are doing well. Inshallah, today we are going to start our first tutorial in statics course. Okay. And as you can see here, we are starting with chapter 2 because chapter 1 is an easy chapter. It's talking mainly about like unit convergence and SI units. Okay. So you can read it by yourself. Now, here in chapter 2, it's mainly talking about vectors, okay, the addition of vectors, dot products, and so on. To make use of our time, let's start with our first problem, okay? But as a quick review, when we want to analyze a vector to its components along a specific axis, we are going to use the parallelogram law or the triangular law, okay? Which says that if we have like the resultant force Fr, okay, and here we have the components. Let's say here it's F2, okay, and here it is F1, and the axes are here. Let's say the axis is B axis, and here the axis is the A axis, okay. So what the parallelogram law says is that we can like make a parallelogram, and the sides of the parallelogram are the components of the resultant force. So F2, we are going to move it in a parallel uh, like direction, okay? And F1, we can also move it here. So as you can see, here is F1 and here it is F2, which are the sides of the parallelogram, okay? And we can also notice that FR is the diagonal of the parallelogram, okay. Another way is that we can say, okay, we can take either this triangle or this triangle, okay, to find the components of the resultant force Fr and find the angles. So we can say, okay, here is F2 and here is the resultant force Fr, and here is F1, okay? So it is like a tip to tail rule. So here is the tip of F2 and here is the tail of F1, okay? So Fr, or we can say F2 plus F1 in the Cartesian vector notation is equal to Fr, the resultant force, okay? And from here, we can use the cosine and sine law, which says that if we want to find the Fr, the resultant force, okay, or the magnitude of the resultant force, it will be equal to F1 squared plus F2 squared minus 2 multiplied by F1 multiplied by F2 cosine the angle between F1 and F2, okay, which is, let's say, theta R, okay. So here the angle is theta R, which is the angle between F1 and F2, okay, and here it will be, or let's say it's theta 1 and here it is theta 2. So this equation is like, we can call it the cosine law, and from the sine law we can get also the magnitudes of the components or the resultant force with the corresponding angles facing the vectors, okay. So we can say F1 over sine the angle facing F1, so F1 over sine theta 1, okay, sine theta 1 equals to F2 over sine theta 2 equals to Fr sine theta r. Okay, so the ratio is equal, and it doesn't matter. We can say sine theta 1 over f1 equals to sine theta 2 over f2 equals to sine theta r over fr. So we can say, like, if we have f1 and the angle theta 1 and theta 2, we can find f2. Or we can take, say, for example, this ratio, and if we have f2, fr, and theta 2, we can find theta r. Okay, so one unknown. So here, let's see what we are given in this problem. Resolve the force F2 into components acting along the U and V axis, okay? And determine the magnitudes of the components. So we are going to use the parallelogram or the triangular rule, tip to tail. And then when we construct this triangle, we are going to use cosine or and sine law, okay? So here is the parallelogram law. Here is the V axis, okay? And here is our U axis. And here is F2 equals to 6 kilonewtons. So we are going to construct the parallelogram. So here is F2, which is equals to 6 kilonewtons, okay? And the component along the U axis is called F2U, and the component along the V axis is called F2V. Okay, and we should be careful here when we are trying to find the angles. So here, let's see what we are given. Here, the angle is 75. Okay, so the angle here will be 180 minus 180 minus 75, which is equals to 105 degrees. Okay, 105 degrees. So here is our axis. Okay, so this total angle also will be 105 degrees, okay? But since we are given this angle to be 30 degrees from the problem, so this angle will be what? Will be 105 minus 30, which is 75 degrees, okay? So here we can take either this triangle, okay? We can move F2U to this side, parallel matter, and here is the resultant force Fr, okay? But I took this triangle, another triangle, okay? So here, taking this triangle, here is Fr, here is F2U, and here is F2V, okay? So here we are given the angle is 30, okay? But what about this angle? This angle will be 75. Why? Because here we have the Z shape. And since we moved F2V to this side parallelly, okay, so it's going to be here 75 degrees. So here is our triangle. Here is 30 degrees, which is given. Here we found it 75, and here we can say 180 minus 30 plus 75 equals to 75 degrees. Or also we can say, let me erase this first. Or we can say also this vector is parallel to this vector, okay? And we have the F shape. So this angle will be equal to this angle, okay? So which is 75 degrees. So anyway, after doing these geometry calculations and math, other steps will be easy, okay? So here we will be using sine law. So F2U over sine 75, which is the angle facing the vector, equals to 6 kilonewtons over sine 75, okay? And we will get the component along the component of the vector F2 along the U axis. And to find the component of F2 along the V axis, we are going to construct this ratio F2V, okay? So here it's F2V over sine 30 equals to 6 kilonewtons over sine 75, okay? And we will get 3.11 kilonewtons. Also, we have another example here about parallelogram and triangular rule. With the magnitude of the resultant force Fr to be 500 newtons, okay, direct along the positive y-axis. So here is the positive y-axis, and the resultant force is directed along it. Determine the magnitude of force F, which is this force, and the direction theta. So we can move like this force using the tip to tail rule, okay, in this direction. So here is our triangle, and we should find the angles and then use either sine or and cosine law. And also we can construct, of course, the parallelogram law or use the parallelogram law. So here is our force F, okay? And here is the angle theta given. And here is the vertical axis, y-axis. And this angle will be what? This is the right angle, so 90 minus theta, okay? And here we can notice that this angle is given to be 15 degrees, okay? With the horizontal. So here is, it's 15, and here it's also right angle. So this total angle will be what? 90 plus 15, which is 105 degrees, okay? And we can notice here, since we move this force parallel, okay, to this force, okay? So here it is what? A Z shape, and they are both parallel, okay? They are both parallel. Let me erase it first. So here is our force, 700 newtons, okay, and it's parallel to it. And this is our Z shape, okay? So this angle, which is 105, will be equal to this angle, which is also 105. So here you can notice it is 105 degrees, okay? So taking this triangle, okay, and after we have found the angles correctly, then everything will be easy. Okay, so here it is 700 newtons, and here it is our force F. We cannot step to tail, and here is the resultant force along the vertical axis, which is 500 newtons. It's given. Okay, and here it is, the angle is 90 minus theta, and here the angle is 105 degrees. Okay, so we should, in our triangle, we should have at least two angles. So here, from the cosine law, okay, because the sine law is F1 over sine theta 1, as we have said, equals to F2 over sine theta 2. So if we have theta 1, F1, and F2, we can find theta 2, FR, and theta R, correct? Because it's sine. So we can use either this ratio or F1 over sine theta 1 with FR over sine theta 1. So to find the force F here, we are going to use the cosine law, okay, which says 50 square root 500 squared plus 700 squared, okay, minus 2 multiplied by these two forces that we have used, 700 multiplied by 500 cosine the angle between them, okay, which is the angle facing the vector F. Okay, that's why it's called the cosine law. So we are going to get the magnitude of our force F, 960 newtons. Now using sine law, okay, so we are going to say sine 90 minus theta over 700 newtons, okay, equals to sine 105 degrees over F, which is 960 newtons, okay? Or we can say, of course, 700 over sine 90 minus theta equals to 960 over sine 105. So here we can notice one equation, one unknown. Okay, so we can find theta equals to around 45 degrees. Okay, and of course we can find this angle. We can say sine 105 over 960 equals to sine, let's say it is theta 3 over 500 in newtons. Okay, here in this problem, as we know, if we have a 2D system, we can get the resultant of the FR in the x direction by simply saying what, or taking the summation of all the forces in the x direction. Similarly, FR, the resultant or the component of the resultant force in the y direction, will be equal to the summation of all the components of the vectors that we are dealing with in the y direction. And the magnitude of the resultant force will be what? Square root, okay, the component in FR in the x direction squared plus the component of FR in the y direction squared. And the angle theta with the, let's say, the positive x-axis will be tan minus 1, okay, FR y over FR x. But here we should be careful about some point. We should know like our vector, the resultant force in which quarter, okay? Because let's say if it is in the second quarter here, so here is FR, and what is required from us in the problem, in the, let's say in the problem, okay? The angle with the positive x-axis, okay? So here we can find theta here, okay? Here is FRY. So here is the vertical component FRY, and here it is FRX, okay? So theta here will be equal to what? Tan inverse FRY, taking just the positive values over FRX, okay? So let's say it is 30 degrees, but what will be the angle with the positive x-axis, okay? It will be like 180 minus theta, okay? So we should be careful in which quarter we are dealing with. And then after we draw our system, we can simply say it is like 90 plus theta. If say, for example, we have found this theta, okay? Here is our theta. So the angle with the positive x-axis will be what? 90 plus theta, okay? So here in our problem, determine the magnitude and direction measured counterclockwise from the positive x-axis. So here is our reference datum, and the angle will be from this axis of the resultant FR force acting on the ring at O if FA equals to 750 newtons and theta is equals to 45 degrees. So simply taking the summation of all the components in the x direction, we are going to say this force 750 newtons, sine 45 will give us the component in the positive x direction. So plus 750 sine 45, okay. Also this force 800 cosine 30 will also give us indeed the component in the positive x-axis. So plus 800 cosine 30, and we will get the result. And since the result is positive, so it is acting in the positive x-axis, okay. Similarly here, taking the summation, the vertical components, the y-axis, So FRY is equal to what? 750 cosine 45. So 750 cosine 45 is positive, okay? 750 cosine 45. And here the component, if we say 800 sine 30, it will be acting downwards, so negative. So minus 800 sine 30, and you will get the result. Positive results, so it is acting upwards. So the magnitude of the resultant force will be equals to square root of Rx squared plus Fry squared, and we will get about 1230 newtons, which is 1.23 kilonewtons. Now, the angle measured counterclockwise from the positive x-axis will be what? Here we are our resultant force Fr in the first quarter. So here is our magnitude 1.23 kilonewtons. Here is the vertical component, and here is the horizontal component. So if we say here is the angle theta, so tan inverse Fry over Frx. So 130.33 over 1223.15, we will get the angle to be 6.08 degrees, okay? So let's say the resultant force is in the third quarter, here theta, okay? And we got theta from tan inverse Fy over Fx with, or taking the absolute value. So if we want the angle from the positive x-axis, we are going to say theta plus 180 degrees, okay? Here also another example. They want the resultant force, the magnitude, and the direction measured counterclockwise. So here, taking the summation of the components in the x direction, here first of all, 15 kilonewtons, okay, sine 40 will give us the component in the positive x-axis, okay, minus 26 kilonewtons, okay, multiplied by 12 over 13 will give us the component in the negative direction, negative x-axis, okay? And the third force, 36, so positive 36 cosine 30, we will get the result, okay, to be 16.82 kilonewtons. What about the resultant in the y direction? Here, the 15 kilonewtons cosine 40 will be positive in the y direction, okay? So 15 cosine 40, okay? And here, the force 36 kilonewtons sine 30 will give us the component in the negative y direction, okay? So negative plus 26, 5 over 13, okay? We'll get the resultant in the positive y direction, okay? So plus, and we will get the answer. Now, the magnitude of the resultant force, okay? We will take square root 16.82 squared plus 3.491 squared, and we will get the result. What about the angle theta? We will say tan inverse. Okay, we can say here absolute value always, but we should like take care. We are in which quarter? Okay, so here we are again in the first quarter. So it's direct. The y direction here, the y component is 3.491, okay, over the x component of the resultant force, which is 16.82, and we are going to get this angle to be 11.7 degrees, okay? Now here, what about if we have vectors or dealing with vectors in a 3D system? It's simply the magnitude, sorry, of the magnitude will be fx squared, okay, plus the component in the y direction squared plus the component in the z direction squared, okay? But we should know that the unit vector, which has the magnitude of 1 and it has same direction of the vector, okay, and it's also dimensionless, can be written as in terms of the what the coordinate direction angles alpha, beta, and gamma. So the unit vector is equals to the vector f over the magnitude, okay, which is equals to fx over fy plus fy over f, okay, plus j, sorry, plus fz over the magnitude f k hat, okay, which is also equals to cosine alpha I hat plus cosine beta j hat plus cosine gamma k hat, okay. And alpha, beta, and gammas are the angles which are measured from the positive x, y, and z axis, okay? So having the range from 0 to 180 degrees. And also here's an important equation or relationship, cosine squared alpha plus cosine squared beta plus cosine squared gamma equals to 1. So if we have two angles or one angle is missing from this equation, we can find the third angle and then we can complete our solution, okay? So here the same concept applies. We are going to take the summation of the forces, okay? But in the Cartesian vector notation, okay? So here, let's start with our problem. Determine the magnitude and the coordinate direction angles, alpha, beta, and gamma, and the resultant force, and sketch this vector on the coordinate system. So here we have two forces, F1 and F2. Okay, F1, we are going to say, okay, here is F1, 400 newtons. If we take cosine 45, we'll get the component in the positive x direction. So 400 plus cosine 45 I hat, okay? What about if we say cosine 60 degrees? We'll get the component in the y direction. So cosine 400 cosine 60 j hat, okay? And here we can notice the angle is given also here. Here it is 60. So if we say 400 cosine 60, which is the angle with the negative z-axis, okay? So we are going to put a minus sign. So 400 minus cosine 60k hat, and we will get this vector in the newtons. Okay, what about F2? F2 also here. Here is F2, okay. If we simply say 125 multiplied by 3 over 5, we will get the component in the positive z-axis. So we can notice here 125, 3 over 5 is the component in the z direction. Now, what about if we say, what if we say multiply 125 multiplied by 4 over 5? So 4 multiplied by 4 over 5, we will get the component here in the xy plane, okay? And then this I'll call it F2 prime. Then F2 prime, if we say cosine 20 multiplied by cosine 20, we'll get the component in the positive x-axis. So here we can notice 125, 4 over 5, which is F2 prime, cosine 20, okay? And it is positive value in the x-axis, I have. And if we say sine 20, we'll get this component, but what? Having a negative sign because it is the negative y-axis. So minus 125, 4 over 5 multiplied by 4 over 5 multiplied by what? Sine 20. And we will get the vector in newtons. Okay? And then simply we are going to add F1 and F2 because here we are dealing with Cartesian vector notations. So algebraic sum. So here we are going to add the components. So 282 plus 93, 200 minus 34.2 minus 200 plus 75. Okay, and we are going to get the resultant, but what? The Cartesian vector notation. Now, if we want to find the magnitude of Fr, we are going to simply substitute in this equation, okay? And we'll get the magnitude to be 430.23 newtons. What about the coordinate direction angles? Simply cosine alpha is equals to the x component of the resultant force over the magnitude, and cosine beta is also equals to the component of the resultant force in the y direction over the magnitude, and gamma is the component in the z direction over the magnitude. So here to find the angles, we are just going to take the inverse, cosine inverse, and cosine inverse. But here we should note that we should take the signs, okay? And we are going to get the values, but these values are what measured from the positive x, y, and z axis. So here I forget to draw the sketch this vector. So Fr is having a magnitude of 430. So let's say here it is Fr, okay, and the x, y, and z. Okay, so here it is x. Let's say here it is the x axis. Here it is the y axis, and here it is the z axis. Okay, z, y, x. Okay, and here the angle will be what? Alpha, which is 28, because as we have said that it's measured from the positive x-axis. Okay, what about beta? It is 67.33. Okay, and the angle with the positive z-axis is what? 106.8. Okay, now here we have another topic, which is the position vector. So as we have just mentioned, the Cartesian vector is, it can be written as f, the magnitude, multiplied by the unit vector. So here the unit vector, we have said it can be like in terms of cosine, alpha, beta, and gammas, the coordinate direction angles, or it can be written in terms of what? The position vectors. So which is r, vector r, okay, over the magnitude of the position vector. And the position vector is simply if we have like a vector in the coordinate system, let's say here the point is B, and here the point is A, here it is R, A, B, okay, R, A, B. So we are going to say, first of all, we should find what? XB, the coordinates, correct? XB, YB, and ZB, okay? And here we should find also XA, YA, and ZA. So RAB will be equal to what? Will be equal to the coordinates of B minus A. So XB minus XA I hat plus YB minus YA J hat plus ZB minus ZA K hat. Okay. And then the magnitude, you can just, as we did here, okay, taking the square root, the first term squared plus the y component squared plus the z component squared. Okay. So let's complete here. Here the idea of this problem is just to construct the position vectors correctly. So here it's given the tension in AB and CD the forces to be 300 newtons and 250 newtons respectively. Express each of these forces in Cartesian vector form. Okay. So we are going just to use this equation. Okay. So first of all, as we have just mentioned, is to find out the coordinates of the points. So here AB, here is our vector AB, and here is our vector CT. Okay. So the coordinates of B here is at the origin, so 0, 0, 0. What about D? Is minus half, because here it's the minus x-axis, negative x-axis, and 0 and 0. Okay, because it didn't move in the neither the y direction or in the z direction. What about the point A? Here we can notice it didn't move neither in the x, positive x, or the negative x direction. What about the y? It has moved this distance, which is 1 meters plus what? 1.5, which is this length, cosine 30. So here it is 1.5 cosine 30. So 1 plus 1.5 cosine 30. What about in the z direction? So this distance will be what? Will be 1.5 sine 30. Okay. So here is 1.5. If we took the sine of the angle, we get this length. Okay. So 1.5 sine 30. What about point C? It has moved in the x direction a value of minus 2.5. So here is the x direction, the x-axis. It has moved in this direction a value of what? Minus 2.5. We can not see it, it's given 2.5, but we should put the negative sign. Okay. What about the y-axis and the y direction? It will have the same dimension as of point A, 2.3. Okay. So here it has moved point A. Point A has moved the same length as point C. Okay, so we can say 1 plus 1.5 cosine 30. Okay, so here it is 1, and here it is 1.5 cosine 30, which is the angle here. The angle here. And what about the z direction? It also have the same z dimension of point A. So here we will say 1.5 sine 30. Okay, so 1.5 sine 30. Now we can find the position vectors. So here, first of all, RAB, okay, RAB, okay, will be what? The coordinates of B minus the coordinates of point A. So we will say 0.0 minus 0 I hat plus 0 minus 2.3 J hat, okay, plus 0 minus 0.75 K hat. Okay, and we get the vector in meters, the units of the position vectors. And now the magnitude of RAB, we will say square root minus 2.3 squared plus minus 0.75 squared, and we'll get the answer. Now, the vector of FAB will be equal to what? The magnitude of FAB, which is given in the problem, 300 newtons, okay? It's given 300 newtons. So multiplied by what? The unit vector, which is UAB, which is equal to what? RAB, the vector, over the magnitude RAB. So here, what we have done, 0 I hat over 2.42 minus 2.3, okay, J hat over the magnitude 2.42 minus 0.75 over the magnitude. Okay, and we will get the answer in newtons because here the units are given in newtons of the force. Similarly here, to find FCD, the vector FCD, we should find first the position vector RCD and the magnitude. So here we are going to say D minus C, okay? So here we can check here D minus C. Here we will say minus 0.5 minus C, which is what? Minus 2.5. So here minus 0.5 minus 2.5 I had. Okay, then 0 minus 2.3. Okay, J hat, 0 minus 2.3 J hat, and finally 0 minus 0.75 K hat. Okay, and we will get the position vector in meters. And also we will find the magnitude, and then we will construct the FCD in the vector Cartesian vector form. So 250 it's given in the problem, and I multiplied it by the unit vector of CD, okay, which is 2 over the magnitude. I had minus 2.3 over the magnitude minus the Z component 0.75 over the magnitude, okay, and we will get the result in newtons. Now, the last part in this chapter, which is an important topic, is about dot product. The dot product, we can benefit from it or use it to get two things. First of all, the angle between two vectors. If we have vector, let's say A, and here is our vector B, okay, and there is our angle theta. So we can say simply theta is equals to cosine inverse, okay, the dot product between the two vectors AB over the magnitudes A and B, okay. And the other way that we are going to benefit from the dot product is that if we have a vector, let's say A, and here is an axis A, okay. What if we want to find the the component in the direction or having the same direction of the axis A or on the axis A? We can simply say A, the magnitude of the vector A along the A axis will be equal to what? The dot product of the vector A, the dot product between the vector A and the unit vector of this axis, okay? But be careful that we will get the result from the dot product is a scalar. So what if it's required to get the answer in the vector like form? We are going to say, okay, AA in the vector form will be equal to the magnitude of AA, which we have found here, multiplied by what? Simply the unit vector of the axis A. Okay? Okay, and the dot product here, if we have A and the vector B, so AXI plus AY J plus AZ K, okay, and here the vector B is equals to BXI plus BYJ plus BZK, okay, the dot product will be what? AX multiplied by BX plus AY multiplied by BY plus AZ multiplied by BZ. And don't forget this root J K. So here is the positive like sign convention. So if we say I hat multiplied by J hat, we are going to get what? K hat. But if we say j hat multiplied by I hat will get minus k hat. Okay. What if we have said like I hat multiplied by I hat will get 0. Okay. So here in our problem, determine what's required. First of all, determine the angle theta between cables AB and AC. The first step is, as we cannot see here, we should find the vector Cartesian form, correct? So we are going to use the position vectors to transform AB, here AB, into a vector, okay? And A and AC, okay? So we should find here RAB and RAC, and then we can use this equation, the dot product, to find the angle between these two vectors, okay? And the second part is what's required is determine the magnitude of the projective component of the force acting along the cable BA. Along the cable BA. So here is the cable BA, and they want the component of this force along this cable BA. So we are going to use what? This equation. Okay. And here it's required the magnitude. If it's required the vector, we will multiply it again by the unit vector of the axis for cable BA. Okay. But I should also mention something. Here we have found, let's say, the magnitude, okay, of the vector along the axis projected on it. Okay, but what if we want to find the perpendicular component? Okay, simply if we have the magnitude, we can say what? A, the magnitude of A minus squared, of course, squared, and here the square root. So here is the perpendicular component. Okay, if we are dealing with scalar notations, but if we are dealing with the vector notation, we are going to simply say, okay, the perpendicular component in the Cartesian form is equals to what? Is equal to A minus okay. So here is our vector A. Here is our vector A, and here is what we have found here. The component along the axis. Okay, so here RAB, we are going first to find what? The uh, the co the coordinates, correct? So here A is 6 6 0 0, here C is 0 1 and 3, okay, because it didn't move in the x direction. Here it didn't move here in the x direction, but in the y direction it has moved 1 in the positive y direction and 3 meters in the positive z direction. What about B? It's also 0 on the x. It didn't move here, but in the y it has moved here 1 meters, but it is a negative, okay, because here is the positive and here is the negative. So it has moved here. And what about Z? It has moved all 2 meters positive, okay? So we want to find first RAB. So we are going to say B minus A. So 0 minus 6 I hat, okay? 0 minus 6 I hat. Then minus 1 minus 0 J hat and 2 minus 0 K hat, okay? So here minus 1 minus 0 J hat and 2 minus 0 K hat, and we will get the answer in meters. Now the magnitude will be what? 6.4 meters, and also we need what? The position vector and the magnitude of the cable AC, okay? Because we are dealing with what? These two cables here, BC and what? AC. Here cables AB and AC, okay? Okay, so here we have got here it will be what? C, the coordinates of C minus A. Not here, the coordinates of C minus A. So we will say 0 minus 6, 1 minus 0, and 3 minus 0. Okay, so here 0 minus 6 I hat, 1 minus 0 g hat, and 3 minus 0 k hat, and we'll get the magnitude of it to be 6.78 meters. Now we are ready, okay, to substitute. So here the dot product will be what? Minus 6 multiplied by minus 6, then plus minus 1 multiplied by 1, plus 2 multiplied by what? 3. Okay, so here is what we have just said, and here the magnitudes multiplied by each other. So 6.4 multiplied by what? 6.78. Okay, so here we can substitute it in the calculator and we can get the angle. Now the magnitude of FBA along the cable BA. Here the projected component of F acting along, so it's parallel to cable BA. Okay, so here notes it's BA, and in part the first part we have dealt with AB. So what will be different is just the minus sign. Notice here RAB will be just here a minus sign instead of positive J hat. Okay, you can simply say, okay, I will do it again. The coordinates of B minus A. Okay, and we will get this unit vector of BA. And notice the RBA is equals to the magnitude of RBA is equals to what? RAB 6.4. Why? Because the minus sign will be cancelled in the squared. Okay, so minus 1 squared is same as saying 1 squared. Anyway, here is our force F vector, which is given in the problem here. Okay, and we have just like calculated the unit vector of BA. Okay, which is this one. So this one dot product with the unit vector. So we will say 400 multiplied by this number. Sorry. So 400 multiplied by this number plus minus 200 multiplied by this number plus the z component of the first vector multiplied by the z component of the second vector, and we will get the magnitude. If it's required the vector, we will say, okay, FBA equals to the vector equals to FBA, the magnitude, which we have already found here, multiplied by what? Here, it's not dot product, multiplied by the unit vector of UBA, which we have already found here. Okay? What about if they are requiring from us or asking us to find the component which is perpendicular? So we'll say FBA, which is the perpendicular component, because here we are dealing with the Cartesian vector notation. So we're going to say, okay, FBA, okay, which is given minus, sorry, here F, which is given in the program, minus FBA, which is the projected component along BA, which is the parallel component. Okay, so here is our force, let's say F. Here is our force F, and here is FBA, which is the projected component along, let's say, cable BA, and here will be the perpendicular component. Okay, so FBA perpendicular. So we are dealing with vectors. But if we are dealing with the magnitudes, we are going simply to say here the magnitude of the force F, which is given in the problem, minus the magnitude of FAB or BA, which is the parallel component. Okay, which is here it is 1875. Here it is 187.5, and here the magnitude of the force F, we can find it simply by saying what? Square root 400 squared, okay, plus minus or positive, doesn't matter really, plus 500 squared. Okay, and we will get the component. Okay, we get the component of the force in newtons. So by this we will end our first tutorial for chapter 2. I hope this was clear, and inshallah we'll meet very soon. Okay, thank you.